Hello and welcome to the CosmoQuest Dawn mission hangout about, well, driving a spacecraft. In today's special event broadcast, we bring you a chance to meet the team behind getting the Dawn spacecraft on its way from the asteroid Vesta and on out to the asteroid Ceres. You get to meet the men and women who plot what's going on every day, keep up with the trajectories, and basically are the day-to-day handlers of this exciting little mission that is showing us the differences between the inner and outer parts of the asteroid belt. This is a two-way conversation, and we're hoping that all of you out there watching will speak up if you've got a question. We have enabled the Q&A app, and you can go ahead and give us a question via the Q&A app from whatever device it is that you're watching this from. If you're more of a Twitter kind of person, then go ahead and tweet at, this is at NASA Dawn, and there's an underscore in there, and we will follow you wherever it is that you may contact us from. Now, I'm going to be mostly the wizard behind the scenes as I let the leader of the flight crew lead this hangout, because that only seems appropriate. So I'd like to turn this over to Tim Weise, who's coming to you live from NASA JPL. Tim, it's all you.
Hello, thank you. Welcome to our control room here in JPL in Pasadena. This is the very room that I was sitting in almost 7 years ago on September 27th, 2007, when the spacecraft launched on its mission to Vesta and now to Ceres. So it's very exciting to use this room to reach out to all the public out there. We have a few of the team members that do the day-to-day operations of the spacecraft with us today. It's probably only about a quarter of the flight team. So there's many more people besides the faces you'll see today. So we don't want to forget the rest of the team. We have Dan Moyers, who's a system engineer. Christina Larson is another system engineer. Ken Starr is our command and data handling, flight software, and fault protection subsystems engineer, so he's pretty busy. Mana Salami is one of our attitude control engineers, and Carrie Bean does science operations support for the flight team. So again, this is just a very small chunk of the team that keep the spacecraft operating. So let's see, like I said, we launched back in September 2007 on our voyage to the asteroid belt. We received a boost from Mars in February of 2009, and then spent around a year exploring the dwarf planet Vesta from the summer of 2011 to the summer of 2012. Now we're in the final cruise to our final destination of the dwarf planet Ceres, and we should be there early next year. It'll be January, February, March time frame. We'll start exploring Ceres. As you may know, this spacecraft uses ion propulsion, which is the first spacecraft by NASA to use ion propulsion as its primary means of propulsion. What ion propulsion is it's about 10 times more efficient than chemical rocket motors. And what it does is it uses electricity from the solar panels to accelerate xenon ions to produce thrust. So this thrust is it's very efficient, but it's very, very small. When we launched, the thrust was about the weight of this piece of paper pushing on my hand. So as you can imagine, it will take quite a long time to accelerate. And you could say it's 0 to 60 in 5 days, for example. That's how long it takes. But over the years, we've been firing the ion thruster for so long that we've actually accelerated the spacecraft by 22,000 miles per hour. So it's very efficient, and it does what it needs to do. It's the only propulsion system that would allow exploring 2 different solar system bodies, which is another first for a NASA mission. Let's see, what else can we talk about? So in terms of driving the spacecraft, basically the people you see around me operate the spacecraft pretty much a 4-week interval. Every 4 weeks, we design a set of activities for the next 4 weeks. The primary objective at this point is to fire the ion thruster to get to Ceres so we can do all the exciting science exploration. So that consists of designing the trajectory all the way out to our first Ceres orbit. And so there's a whole navigation team, which you don't see today, that their primary job is to measure where the spacecraft is currently, predict where it's going to be, and then design the maneuvers that we will do until we get to Ceres to get into orbit around Ceres. And so that's done every 4 weeks, and some of the team members here will talk about a little bit more of the details of that process. As we approach Ceres, you can kind of think of it as we're matching the orbit of Ceres around the sun. So we're not going to do a big maneuver like they have going into Mars, where the spacecraft turns and fires a big rocket motor to slow down. We just sort of match the orbit and then gently nudge the spacecraft into a spiral orbit around Ceres and slowly shrink that orbit down until it's into the altitude that we need to do our exploration. So with that said, I'll let some of the team members talk in a little bit more detail about what they do. So we'll go ahead and start with Dan Moyers, a system engineer, who will be busy on Monday in this very room that he'll talk about a little bit.
Sure. Hi, everybody. As Tim said, I'm a spacecraft systems engineer here on Dawn, and a lot of the things I work on day to day are planning activities for the spacecraft, to tell it what to do and how to get to Ceres now. We just approved our latest batch of commands to send to the spacecraft earlier this week, and on Monday morning we will be coming in bright and early to send those commands. So we'll be on console, and just over here the ACE will hit the button to fire the commands off to Madrid, Spain, where they will radiate through the antenna and up into the sky and all the way out to the Dawn spacecraft, which is currently 270 million miles from Earth. So being that far away, and for the files traveling at the speed of light, it will take about 24 minutes for the commands to get to the spacecraft. So there's a little delay in sending the commands and then getting a reaction from the spacecraft. But on Monday, we'll be sending the files that will tell the spacecraft what to do over the course of next month. And this will include thrusting, and we'll tell it where to point in order to appropriately get to Ceres. We'll also have special activities with instrument calibrations for the framing camera. We're also going to do a power experiment that will help us determine how much power we will have available when we get to Ceres for all the activities we'd like to do there, and various other maintenance activities that we do from time to time to make sure the spacecraft stays healthy. So that's a little summary.
So this actually starts to touch on one of the questions that we have from our audience. We have someone whose username is Sizzlebread23 asking, how much is nominal planning versus mini crisis planning versus major crisis planning? So what are all the different things that you have to take into account as you're figuring out where your mission's going to go over the next days, weeks, and months?
Okay, I'll take that. I think most of our planning is nominal planning. We have contingency procedures that we developed before launch or earlier in the mission that we will open up in the event of a problem with the spacecraft or the trajectory or that sort of thing. So there was some level of effort to produce those, but it's relatively small percentage compared to the day-to-day operations. And then if there is a problem, we have to react to it. And so it just depends how the spacecraft is behaving into how much effort we spend on that.
So you're sending all of the commands out for the next month. What else is going on with this large team of people that you have arrayed in this room?
Okay, so let's go to Christina Larson, who's going to talk about part of our process is to simulate a lot of these commands here on the ground. So she'll tell us about that.
Okay, so a lot of time that I spend preparing for sequences is in the test bed, which is just down the hall here, and it's basically a simulator of the spacecraft. And we have copies of uh, flight hardware in there, as well as software simulation of the rest of the spacecraft. And we use all of this to run activities, any new activities that we're going to do, run our sequences through so that we can find any bugs, find any issues ahead of time, as well as just understand how the spacecraft is going to react to what we're sending up and have a better understanding of that before we send it in real life. And it's a very cold, cold room. We keep it cold to keep the hardware and electronics happy, and so sometimes it requires a blanket or two to do work in here. But so we spend quite a bit of time in there, and it simulates in real time. So if you have a sequence that takes 3 days to run, you can't speed this up. Your test is going to take 3 days, and so sometimes it's a bit of work, but it's a great way for us to really perfect our sequences before we send it up to the spacecraft. And one thing that we've been working on lately is building all our sequences for Ceres, which may seem very ahead of schedule or very early, but the point is that we get everything built, we run it through the test bed, and we find everything that we can find early on so that we're ready to go when we get there.
So you're working on developing this great mission. You're testing out all of the commands ahead of time. And I know one misconception that a lot of people have is it's Han Solo's asteroid belt, and you're diving between various rocks. Can you help explain more of what the real journey is like for this poor lonely spacecraft?
Okay, I'll take a stab at that one. Unfortunately, real science and spacecraft operations isn't nearly as exciting as flying the Millennium Falcon through an asteroid belt. In our asteroid belt around the solar system, there's a lot of rocks and debris and that sort of thing, but it's very spread out, and so the chances of us even coming close to anything else is extremely small. So we don't do any special maneuvering to avoid them or anything like that. Since we have a Star Wars reference, if you know what the acronym for the TIE Fighter is, it stands for Twin Ion Engine. So there's your translation from science fiction to science fact, and we're actually using that technology.
It's just much slower to accelerate. I think the best analogy I've heard for your actual ion engine is imagine standing there and hurling BBs while wearing ice skates, and you'd very slowly, thanks to conservation of momentum, start moving, but you're going to have to throw a whole lot of BBs before anyone can notice that motion. And you guys are basically throwing BBs. They just happen to be even smaller, but moving so much faster. And it's that speed at which you're flinging atomic bits out of your spacecraft that really allows you to keep going. Now, it sounds like there's a whole lot of nothing out there. You're sending commands once a month. What all is involved other than sitting and waiting for the science to come in the future? You come in each day and you go, yep, still working, and then what do you do next?
Why don't we jump to Mana a little bit, and she's one of our attitude control engineers, and she can explain a little bit more of what goes into figuring out the orientation of the spacecraft and making sure that aspect of the spacecraft is performing nominally.
Okay, so from the attitude control engineer, it might seem like, it's a little tough job. We're supposed to put a smile on the spacecraft, but basically what we do is determine and control the orientation of the spacecraft. Let's say when we're communicating with Earth, we want to make sure our antenna is pointed at Earth, or let's say when we get to Ceres, we want to make sure that our camera is pointed in the right direction so we get the best picture, for the science that we're doing, because basically that's the whole, purpose of doing this mission. So For the sequences that we already talked about, we provide inputs to our systems engineers and basically do a thorough review of the activities that are going to be done, during that whole month, and make sure, spacecraft is behaving as it's supposed to, it's pointing where it's supposed to, and we have simulation software that take care of that. And also sometimes, we're doing activities that we need to send to testbed, so that's when I usually go to Christina and bug her and have her go to the cold room that she talked about and, perform those tests. So everything is well planned, and like Christina said, we are right now doing, planning for Ceres months ahead of time. So basically planning for the future and making sure all our science activities, all the right pointing is in place. So when we get there, it's going to be a much easier task.
So you have the altitude controls that you're working on. And this actually ties in nicely with a question that we have coming in, again from Sizzlebread, and then I have questions from other people to get to as well, where he says altitude control with 4 versus 2 reaction wheels while trying to save propellant seems like an extremely different process. How is it operationally, and how difficult does it make the planning?
Okay. Should I take that one? So right now, basically, we have everything planned for a successful mission. Yes, we are 2 reaction wheels down, but we have what we call the reaction control system. So basically, we have these little thrusters that perform, the controlling of the spacecraft for us. So we do the turning with those, and no need to use the reaction wheels right now. But everything's planned for Ceres, and we've planned everything, so it's going to be a successful mission. So.
And I promised to get to another question from someone else, and Thomas Traniker is asking, when Dawn reaches Ceres, what is the largest hope for the science to find? Is it finding water, geologic features, or something completely different? So what are your scientific hopes and dreams? And just broad brushstrokes is fine. I know today's big story is about how do we get there.
So I think Carrie Bean, who does science operations support, would be a good person to answer that.
Great. So we have 3 different instruments on board the spacecraft. We have the VIR instrument, which is a visible and infrared spectrometer, and we also have our framing cameras, and then we also have the grand instrument, which detects gamma rays and neutrons. So we have 3 different instruments that we're able to look at. And so we have this great suite of instruments to be able to look at Ceres with, and personally, I'm really excited about the water vapor. It was recently detected by the Herschel Space Telescope that there was water vapor around Ceres, and my background is in Martian meteorology, and so I'm really excited about this opportunity that there may be an atmosphere. And so the unfortunate bit about that is it was dependent on how far away Ceres was from the sun, and when we get there, we're going to be further away when they weren't seeing the water vapor. So there's a chance we may not see anything, but the data point either way is important. And also, Ceres has been studied for a really long time. It was discovered before Pluto, and yet we barely know anything about it. And so it'll be really exciting regardless of what we see.
So I think this opens up the interesting point. Yes, Ceres was discovered before Pluto, and just like Pluto, it was actually misidentified as a planet. And so now we have 2 objects in our solar system, both of which have been demoted. And with the combination of Dawn getting to Ceres in 2015 and New Horizons getting to Pluto in 2015, we will have visited everything in our solar system that was ever called a planet. But what is it about Ceres that makes it so different from Vesta and makes it worth going to both of these worlds? This is a question I see cropping up in our questions from multiple people.
So Ceres and Vesta are the most massive objects that we have in the asteroid belt, and Vesta is also the brightest object in the asteroid belt. And Ceres also, because it's so massive, is actually round like a planet. So it's really more like a planet than an asteroid. And even Vesta is a lot bigger than your normal asteroid. And so these objects are so much different than the other asteroids that we see out there because they're so big. And so also Ceres, along with the water vapor detection, there's some speculation that there may also be a subsurface ocean. So that's so different than an asteroid. So it's just going to be really cool, whatever we see. And the scientists are still poring over the Vesta data and still coming up with new great discoveries. So it's a really good mission for asteroid science.
And does this mean that there's a difference in the planning for how you're going to explore the two different objects? Will the instrument usage vary from Vesta to Ceres?
Not much. The kind of coming from the Mars background, well, Mars, it's like you find a new thing every day and you plan to look at all the different things. Dawn really has the view of you're going to take a picture of everything so you can't miss anything. So we're really going to map the whole thing and get as much data as we possibly can. We'll try and look for the water vapor, but we may or may not see it. And that's a little bit different than what we did on Vesta, but pretty much everything we planned from Vesta. Our Vesta mission was extremely successful, so we want to carry on that mindset and that way of we planned our sequences, so we'll be able to carry on our mission at Ceres and be very successful.
And so we're in a situation where right now you guys are demonstrating the vast diversity of skills that are needed from sheer management to simulations to hardware to software to scientists working with the engineers and the software developers and technologists. How do you bring all your skills together day to day to make sure that everything that needs to happen happens? Tim, I'm going to hand this back to you.
Yeah, one of the biggest parts of my jobs, I actually have two roles as Deputy Mission Manager as well as the Spacecraft Team Lead. And out of the people in this room, I've been on the project the longest. I started back in 2004, 2005. Actually, my oldest son was in first grade when I started on the project, and he'll be graduating high school when we're still at Ceres. So his entire primary education was done with me working on this project. And a lot of my job has been to make sure that we have the right skill sets on the team, and if we don't, find the people that do, and then delegating the right tasks amongst the team members. And so a lot of it is identifying who's good at what aspect, and assigning the tasks appropriately. As we were talking about the reaction wheels earlier, we formed a whole Tiger team with the appropriate people, even from outside of the project.
Can you explain what a Tiger team is for people who might not know?
Sorry. A Tiger team is something that's formed at JPL when there's a significant issue brought up on a spacecraft. It can be, for any number of things. And so it's a mechanism to provide industry as well as subject matter experts that may not be part of the project, and it provides the project that access to those resources to be able to do the best job figuring out what the appropriate next steps are.
So that all sounds really cool, and there's still some people here that we haven't heard from, so do you want to introduce some more of your team members to us?
Yes, I was just thinking about that. Ken Starr, who's actually been doing a lot of investigation in how our fault protection design works and flight software. He's one of the newer members of the team, so he didn't get to experience Vesta like some of us had, so Ceres is all new for him, and he's trying to make sure he's well prepared for the encounter.
So Ken, you want to tell us a little bit about what you work on?
Sure. As Tim said, I'm one of the newer members of the team, but I do have a background from a lot of different flight missions, and my primary responsibility is to actually know what the spacecraft is programmed to do and how it does it, and as people develop the sequences and so forth, check over to make sure that that's consistent with what the performance of the spacecraft is, that it's following rules that we have set up. And also, as far as fault protection goes, fault protection is piece of the onboard software that monitors the spacecraft internally. It actually has about 250 monitors that are watching different data points. And so when we're not in contact with the spacecraft is monitoring itself to make sure that things stay within the expected range. And if anything ever gets out of range, there are another set of, again, 250 responses that can autonomously take over and take some pre-programmed action based on what it's seeing. So these are all. This goes back to the question about normal versus anomalous behavior. These are all things that were thought of long before launch, that the system was programmed to look at, and in case it happened, it has certain actions which might be as simple as telling the operators that something has happened, to taking autonomous action to swap to a redundant, a piece of hardware that's there just in case something goes wrong with the primary.
So this is sort of like the messages that so many of us see on our computers, along the lines of, you haven't backed your hard drive up in N days, or your CPU is too hot. I know I get that one on my phone all the time for leaving it in the car. These are just the standard something went into the red type messages, but with a spacecraft it's a whole lot more important than with my desktop computer.
Since we only talk to the spacecraft every few days or up to once a month in the case of the larger data chunks, it has to have a certain amount of autonomy, because it can't sit there and let a problem continue. So it has to take care of itself, and it has what we call a safe mode. So if things really go bad, it goes and makes sure the spacecraft is safe until our operators can get in there and take corrective action to get it back to working normal.
And so this really opens the question up of, how do we talk to it? A lot of people think that, oh, there's just some constant two-way communications, but no, that's not the case. With Dawn, how are you able to listen and communicate?
Okay, well, as I was saying, we send up, have an opportunity once a month to get a large dump of data. We go to our high gain antenna, and we get a large chunk of data back. It usually takes about a day, 8 hours or so of data time to get this down through the Deep Space Network. But we also talk to the spacecraft a couple times a week across the low gain antenna, which means we can get a small amount of data at a time, and that just tells us that things are healthy, we're continuing to thrust properly, and that things are going according to plan. If that weren't true, then we'd be able to go ahead and intervene, get some additional time on the Deep Space Network, and go find out what the problem is and fix it.
And the Deep Space Network is something a whole lot bigger than just the antenna that you have there at JPL. Here you're looking at, in some cases, multiple telescopes spanned across the planet, all giving your spacecraft a listen.
The Deep Space Network is an asset of JPL that's used by all missions, and in fact, not only JPL and NASA missions, there are missions from space agencies around the world that use our Deep Space Network to communicate with spacecraft that are out there. And there are 3 major stations around the world that they're spaced out pretty much equally around the world, so that we can always talk to a spacecraft if we need to.
And one more question before I hand this back to Tim. You have a kind of weird-looking clock up above you that says 227 with a counting clock. What is that clock up above your head?
Well, because the Deep Space Network works on a global basis, we have 3 stations. That actually shows what's called UTC, Universal Time, which is equivalent to Greenwich Mean Time. And what you're seeing is the first number is the day of year, and then the time that's in that central time scape. So we always communicate in that. So we have that up there. So when we talk with the stations, we know what time it is that the stations are talking, and also that's relates to our spacecraft also.
All good. So Tim, you're bringing together all of these diverse, different ideas, concepts, things that have to be done. What are the types of things that you worry about day to day as you keep your spacecraft on target?
Let's see, just about everything. You know, at this point, any interruption in thrust or the spacecraft operations would affect the arrival at Ceres and different things. And there's just a multitude of things that could happen. The spacecraft electronics can be sensitive to what are called particles called galactic cosmic rays. And so basically, it's like radiation on your computer, and it can flip what we call flip bits within the memory or in the electronics and change how it behaves. And we've actually had a couple of those instances previously on the mission, and you're perfectly fine. The bit flips and then it recovers, but it may put a glitch into our operations day to day. So there are things that we can't control like that. And then, as Dan was speaking about, building these month-long sequences and making sure every command in that sequence is correct and double-checking that it's doing the right thing. The timing and spacing between the commands is all configured correctly. It has to be done with diligence. We've done we label our sequences according to the phase that we're in, and so right now we're in cruise phase, and so the sequence that Dan is planning on uplinking on Monday is sequence number 75 since launch. We've done 75 of these cruise sequences that are about a month long since we've launched, and by the time we get to Ceres, we'll do a few more, so we'll be up around 80. And that's not even counting all of the year-long of encounter sequences at Vesta. So that level of diligence that everybody across the team has to maintain, just so we don't miss something falling through the cracks and messing up our day.
Yeah, related to that, Hugo Burnham is asking, do you have a clock for the total elapsed mission time?
I think I've seen that in various places, but our launch anniversary is September 27th. So that will be 7 years. We launched, it was like 4:30 in the morning here, dark early for those on the West Coast. It was a beautiful sunrise launch with the sun in the background. If you've seen pictures on the webpage of launch day. So that's our reference point, but we don't typically reference it because it's the excitement is yet to come at Ceres.
Now, as you're working on this mission, I know some people have the misfortune of having to, or fortune, depending on your point of perspective, to spread their time across multiple spacecraft. Do any of you in the room right now, Sizzle Red is asking, what other missions or projects do you work on? Is it helpful to have crossover between missions in how you spend your time?
So I'll speak a little bit on that. I think Mana is the only person here that right now is splitting her time with other projects. But we do have one of our engineers that maintains the reaction control subsystem that Mana spoke about with the chemical thrusters, also works on Cassini. He worked on the Curiosity, the landing system, all the rockets used for that. And so he's able to bring that experience and performance knowledge on how those systems worked on the other missions into our mission. And so we were able to take advantage of that. Mana, do you want to speak any about your other efforts?
Sure. So I'm half-time on Dawn, which is in the operations phase, and the other half on Europa pre-project. So Europa is Jupiter's icy moon, and there are multiple studies going on right now in hopes of getting funded to become a mission. So that's basically a concept right now, and it's a really good balance, and I'm learning a lot on both projects that are useful on what I do day to day on both of them. So it's really fun, both a great experience.
And this definitely reminds us all that you often will spend decades working on a mission, but then when it's over, you have to figure out, what do I do next? And part of that is also figuring out how you end your mission. And we have pretty much that question going on right now. What will the end of this mission look like once you get to Ceres and make your orbits and map everything out? Then what? What's next for the spacecraft?
So the plan right now is that we will we have funding approved from NASA headquarters to go through our primary mission objectives. That'll take us through about June of 2016. If we happen to have more fuel available to keep the spacecraft operating, we'll continue to take science in that same last low orbit that we will spend several months in as part of our primary mission. If NASA can give us, some extended mission money, we'll continue to refine our knowledge about Ceres by continuing to do observations and refining the gravity field and just continuing doing the same thing in the same orbit as long as we possibly can.
Now, Carrie mentioned the possibility of water, which I have to admit I missed that journal article, so I find that highly exciting. There's a lot of concern with some of the moons of Saturn and Jupiter that we don't want to accidentally crash a spacecraft into one of those moons in case they support life. Now, I've heard absolutely no one making the argument that Ceres might have life, but what do you do with your spacecraft when it's done orbiting? It's a horrifying question. It's always bad to ask, but sometimes you get to land them gently.
Right. It's definitely a unique perspective that up till recently everything has been planning for the encounter in the future, and now we're saying, okay, well now what do we do? Basically, we're just going to continue operating the spacecraft as long as possible. Our navigation engineers have studied the orbits and the gravity field and determined that the spacecraft will be in an extremely stable orbit for at least 20 years. And so we actually have planetary protection requirements that indicate, we need to show to NASA that the orbit will be stable, and those are the measures that we basically take, and then we can leave the spacecraft in orbit and it'll be stable and spend the rest of its life or existence there.
That is a really nice change from what we normally do to spacecraft. So it's good to hear that she'll be allowed to just keep circling away. So you made it to Vesta. We got amazing maps from Vesta that we're working really hard to try and map out with asteroid mappers over here at CosmoQuest. You're going to go to Ceres, and I know we're planning to stick with you so that we can map out Ceres. In terms of all the planning, what lessons learned do you have from what you did at Vesta that you can carry forward now as we go to Ceres, we now know we need to? What did you learn that changes how you're going to approach Ceres?
That's a really good question. I don't know if anybody here on the team wants to add to whatever I say. I think the main thing is the planning that we did ahead of time for Vesta worked very well. We were able to be prepared to react to the final updates when we got to Vesta, and so we repeated that action. Like I think Christina mentioned, we're pre-building all of our Ceres encounter sequences. That was one of the biggest lessons learned from Vesta, was to pre-build them. And when we were approaching Vesta, it was all new. We had all kinds of different things to figure out, and now we kind of we got a dry run for our Ceres encounter. So that was kind of our rehearsal, and now we know what we're doing much better. And we actually are pre-building many more sequences than we did for Vesta. We didn't have enough time in our preparations for Vesta, but now we have the time and we put more detail into it, so we're better prepared.
That's we don't think of choreographing spacecraft like dancers, but it really is a requirement. You can't just put it up there and wait for it to circle all the interesting places. It's always interesting to think through what's required to get out the science you all are getting out. Now, as this mission has progressed, I'm sure you all must have your favorite moments or have things that you're particularly looking forward to in the future. Perhaps in these last 15 minutes, we could hear a little bit from each of you about what has been either your favorite moment so far or the thing that you most look forward to in the coming days, months, and actually years that this mission is planned for. I'm going to start all the way over to the left and throw this to Dan.
Sure. So I'm actually really excited about getting our first images of approach at Ceres, where in late February we'll have the highest resolution pictures ever taken of Ceres. And I think once we get close enough that Ceres fills up the full camera frame of view, it's just going to be spectacular and amazing because no one has seen it in that much detail before. So it's really worth the effort to get there, and you really feel accomplished when you make all the efforts and work really hard to help the team get that science data and see these new worlds that have never been seen before.
I have to admit that's a moment I'm looking for, especially after the Vesta moment of what the heck, because Vesta is really the asteroid Dr. Seuss created. And now we get to see Ceres. So are you going to be part of the team that gets to see the data as it comes down from the spacecraft?
Yes, I'll be sitting on consoles staring at my screen, so I can't wait for it.
That's going to be an awesome day, and I look forward to it, and maybe if we're lucky we can plan a hangout around that so that we can share at least some of that moment with the world. But that's all getting ahead of myself. For now, let's Ken, what are you looking forward to being the new guy on the mission?
Well, for me, I've spent most of my career here at JPL working on missions prior to launch. I've worked on a lot of different missions, including Cassini, MRO, Deep Impact, MSL, but all of them were missions that had, I got them ready to launch, and they were off, and I was off to the next project. So this is the first time I've had a chance to actually see a mission flying, and it's been a lot of fun because you actually get to see, the results up close firsthand. And as far as what I'm looking forward to out of the mission, every mission I've seen, the most exciting part, I think, is the parts that we didn't expect. And so I don't know what it is that I'm going to really be excited for, but there's going to be something out of this mission that no one thought they were going to see. And that's always the most exciting part about these missions, because it's just data that no one anticipated.
Awesome. So Carrie, you're new to asteroids. You're coming to this from atmospheres, which Ceres doesn't so much have, and Mars, and so what is it that has you most excited with so much new science for you to look at?
So I like to say that Ceres has decided to have an atmosphere just for me. So that's what the water vapor's for. That's just to make me happy. But even just then, the story of water in general, even if we're not seeing the water vapor, just the story of water and ice on Ceres is going to be really exciting. Vesta was the size of Arizona, and look how many interesting things they found. And Ceres is about the size of Texas, so that's even more. So there's really going to be great stuff that we see.
And I'm sure there's going to be a bumper sticker out there at some point, Ceres bigger than France. For those of you not from Texas, there was for a long time a billboard that said Texas bigger than France. So this is an inside joke for all of you Texas geological lover people out there. So Christina, what are you most looking forward to other than not having to be in the cold room anymore?
I'll still be in the cold room. But, well, I started interning on Dawn back in 2008, shortly after launch, and I remember at that point Vesta seemed so far away, and it was so much time until we were getting to Vesta, and then Ceres was just, we'll think about that eventually, but Vesta was so far away, and now that we're so close to Ceres, I'm excited for when we are officially in orbit around Ceres. I remember when we were first in orbit around Vesta, it wasn't, some big, huge, climatic thing that happened, but we got an email that said, hey, we're in orbit around Vesta, we're officially in orbit. And so to us, that's a big thing, and I'm excited for that moment when we're officially in orbit around Ceres.
So this actually hits on a point that a lot of people miss. Because of your ion drive, there's a whole lot of, are we in orbit? I'm not sure if we're in orbit. I think we're in orbit. Can you maybe address that a little bit? Or do you want to hand it over to somebody else?
Maybe Tim can answer.
Okay. Sorry, Tim, I'm going to hand it back to you.
Oh, no problem. Yeah, you're right. It basically, at Vesta, we weren't even tracking with the DSN when we entered orbit. We were firing the ion engine, and we just gently nudged ourselves into the influence of the gravity of Vesta. And when we had our next contact with the DSN, the navigators, we could confirm that the spacecraft continued thrusting, and then the navigators confirmed with data from the DSN that the thrust did what it was supposed to do, and confirmed we were in orbit.
Cool. So Nana, what are you most looking forward to, or what has already happened that excited you so much?
So I've been part of the team, so I'm one of the newer team members as well. I've been part of the team for over a year now, so I didn't unfortunately get to experience Vesta, but I think the most exciting moment for me was when I provided my first sequence inputs. It was like nerve-wracking, at the same time very exciting. It's like, oh my god, I'm actually sending something up to the spacecraft. And what looking forward to, I think every single picture that we're going to take from like the first image to the very last one, I'm really looking forward to see all of them, because I think every single one is going to reveal something different, and I'm just super excited about that.
That I fully understand that. I know I look forward to every image that you guys get as well, and look forward to sharing them out with everyone over at Asteroid Mappers. It's amazing how much imagery there is when you start to think of, well, each image is such that boulders are tiny, and we're mapping out something, well, before the size of Arizona and now the size of Texas. When your images are such that boulders are only a couple of pixels across but still fully visible, it's going to require a whole lot of photos to show every boulder that's out there, every crater, every wrinkle ridge, and every other geologic feature. And you guys are sharing them with the world, which is commendable. Now, before I give Tim the last word as we look to round up this hangout, I'd like to point out to all of you who've been with us for the past 50 minutes as we've gone on a wild ride with the flight team, there is actually a survey that we'd love it if you would fill out. If you can go to the Dawn event page, just go to Google+, type in the Dawn event if you're not watching it from there. Look at our Twitter links. We'll link out the link for the survey. We're just trying to find out what it is that you like most and you like least about how we're doing this hangout, and we'd really appreciate your feedback. So take a minute, give us a little bit of feedback, and while you're doing the survey, when you're done, take a few minutes to explore the NASA Dawn website and learn about all the interesting science that's going on that we weren't able to fit into this brief 1-hour hangout. Now, Tim, you've been doing this, well, since your child started first grade. This is a lot of your life tied up into one little spacecraft. What is the thing that keeps you coming into JPL every day to keep the spacecraft flying through the solar system?
There's two aspects. It's really, really cool, and it's a really great team. It's been so rewarding seeing everybody growing. We had a lot of new people, like Christina said she was an intern when she started. We've had other people that have grown in their roles from, an engineer to a team lead type position, and just seeing everybody, moving up like that. And as we approach Ceres, I share Dan's excitement for approach. When we came into Vesta, and every picture we took was just a little more resolution, and it was getting bigger in the picture, and the details started coming out, the grooves and the craters and everything else. Just seeing that evolve from the poor Hubble resolution into detailed images of Ceres, I can't wait. It's going to be awesome.
And we're going to be here to help follow you through the next year, and starting in February with the first images all the way to when you start orbiting. And for those of you who are still trying to wrap your head around an ion drive and reality versus fiction, there's a great interactive activity over on the Dawn website that I'd encourage you to check out. Just Google Dawn ion propulsion activity, and that should get you there. We're also going to tweet and post to the event page the link to get you to that activity. And for those of you who want to start today helping the Dawn mission do science, go to cosmoquest.org and check out the Asteroid Mappers project. We have partnered with the Dawn mission to take the imagery and provide it out to you along with simple-to-use tools that will turn you into an asteroid cartographer. And we're still learning what there is to learn. We're still trying to understand what it is that takes a mostly round asteroid and squishes it so it gets, well, wrinkles around its waist. And you can be part of helping us, well, discover our universe. So thank you so much for joining us all today. You have all been wonderful guests, and we're going to keep at random intervals bringing you these Dawn special events so that you can keep up with how this mission is keeping on trucking across our solar system. So thank you all for joining me today. This has been a great hangout, and I hope to see all of you online later at cosmoquest.org and on the Dawn website. Thank you very much.